Okay, detecting radioactivity. Radioactivity can be detected because the particles that are emitted interact with other atoms or molecules. And so we can look at that interaction and measure radioactivity. This detector here is actually a change since the previous edition of the textbook. So this is interesting. So a thermoluminescent dosimeter. A dosimeter measures a dose, right? So this is used to measure exposure of a person to radiation. This doesn't measure instantaneous radiation, but it'll measure the dose of radiation that you've received over a certain period of time. So anyone who works with radiation or near radioactive substances is required to wear some sort of a monitor so that you can make sure that they're not getting exposed to too much radiation. So this would be periodically tested. So the way this works is the badge contains crystals of salts, such as calcium fluoride, that are excited by ionizing radiation. So the salt is sensitive to ionizing radiation. And the salt that they put in there has impurities in it that were intentionally put in there that will capture those excited electrons. And then when you heat this, those impurities will release as light the energy that they received from those electrons. So the amount of light, how much it glows when it's heated, is related to the amount of radiation that the badge has been exposed to. Does that make sense? And so what they do is they would monitor these, take them out and heat them and monitor them at specific intervals to make sure that you're not getting too much radiation. Any questions? To detect radiation in real time, you might use a Geiger Mueller counter, typically just called a Geiger counter. And this is the sort of thing you see in movies and TV shows where, something's radioactive and you hear this click, 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 right? That's a Geiger counter. So the way this works is there's a chamber filled with argon, and particles pass through this. The particles from the radiation pass through this chamber, and they create a trail of ionized argon atoms, because this is ionizing radiation, right? So as these particles hit the argon atoms, they ionize the argon. So we apply a voltage, a high voltage, across this, and when there are ions present, it conducts and there's current. If there are no ions, there's no current. And so that current can be transferred or transformed into a reading on a gauge or to an audible clicking sound, or sometimes both. And so it's the ionization of argon atoms that's being measured. It's a Geiger counter. Any questions? Another method is called a scintillation counter. Also measures radioactivity in real time. So here they use a material such as sodium iodide or cesium iodide that is going to emit either UV or visible light when it's exposed to ionizing radiation. And so then the light is monitored, turned into an electrical signal that's read on a meter. And so you can instantaneously measure radioactivity.